According to the National Electrical Code, Section 300.4 states that insulated bushing nuts are required on conduit fittings that contain conductors of 4 American wire gauge or larger. Sections 342.46, 344.46, and 362.46 state that bushings are required on all conduit entering a box unless the box or fitting is designed to provide the same protection. Based on these code requirements, several points can be made. Firstly, EMT fittings generally do not contain conductors of 4 American wire gauge or larger, so insulated bushing nuts are not required unless such a conductor is present. Secondly, Romex connectors are not specifically mentioned in the NEC regarding bushing requirements. However, since they are essentially conduit fittings, it is reasonable to assume that they require a bushing when used with conduit that enters a box or fitting. If a box or fitting is designed to provide the same protection as a bushing nut, then a bushing nut is not required on the conduit entering that box or fitting. This is typically the case with certain types of junction boxes and weatherproof fittings. An argument that insulated bushing nuts are required on all conduit and fittings 3/4 inch or larger is not supported by the NEC. The code only requires bushing nuts on conduit fittings containing conductors of 4 American wire gauge or larger and on all conduit entering a box or fitting that is not designed to provide the same protection. Therefore, it is the understanding of the code that is correct. Insulated bushing nuts are required on conduit fittings containing conductors of 4 American wire gauge or larger and on all conduit entering a box or fitting unless the box or fitting is designed to provide the same protection. EMT fittings generally do not require insulated bushing nuts, and Romex connectors require bushing nuts when used with conduit entering a box or fitting. When dealing with electrical installations, understanding the National Electrical Code, or NEC, is crucial for safety and compliance. One common point of discussion revolves around the requirements for insulated bushings and their application in various scenarios. Let's delve into the specifics of insulated bushings, their purpose, and the code requirements that dictate their use. Insulated bushings are protective components used in electrical systems to ensure the safe passage of conductors through enclosures and fittings. Their primary function is to provide a smooth, rounded surface that prevents damage to the conductor's insulation as it enters or exits an enclosure. This is particularly important when dealing with larger conductors or when the edges of the enclosure opening are sharp or abrasive. Now let's explore the key sections of the NEC that address the use of insulated bushings. Section 300.4 F of the NEC focuses on the protection of conductors from damage. It specifically requires that where conductors of size 4 American wire gauge or larger enter a cabinet, box, enclosure, or raceway, they must be protected by an identified fitting providing a smoothly rounded insulating surface. This requirement aims to prevent abrasion or other damage to the conductor's insulation, which could lead to shorts, ground faults, or even electrical fires. In addition to Section 300.4, F. Other sections of the NEC provide further guidance on the use of bushings in specific applications. Sections 342.46, 344.46, and 362.46, which pertain to intermediate metal conduit (IMC), rigid metal conduit (RMC), and electrical non-metallic tubing (N), respectively, all contain similar language requiring bushings or equivalent protection where conduits enter boxes or fittings. These sections emphasize the importance of protecting conductors at entry points to prevent damage and maintain the integrity of the electrical system. One common point of confusion is whether insulated bushings are required for all conduit fittings, regardless of the conductor size. The NEC is clear that insulated bushings are specifically required for conductors of size 4 American wire gauge or larger. However, it is also important to consider the overall protection of conductors, regardless of size. Even for smaller conductors, sharp edges or rough surfaces can cause damage to the insulation over time. Therefore, it is generally good practice to use bushings or fittings with rounded edges to protect all conductors, regardless of size. Now, let's address the specific cases of EMT fittings and Romex connectors. EMT fittings, which are used with electrical metallic tubing or aimed, typically do not contain conductors of size 4 American wire gauge or larger. Therefore, insulated bushings are not specifically required by the NEC for EMT fittings unless they are used with larger conductors. However, it is still important to ensure that the EMT fitting provides a smooth, rounded surface to protect the conductor's insulation. Many EMT fittings are designed with integral bushings or rounded edges to meet this requirement. Romex connectors, which are used to connect non-metallic sheath cable, also known as Romex, to boxes or enclosures, are not specifically mentioned in the NEC regarding bushing requirements. However, the general principle of protecting conductors from damage still applies. Romex cable has an outer jacket that provides some protection to the individual conductors inside. However, the edges of the connector or the enclosure opening can still pose a risk of abrasion or damage to the conductor's insulation. Therefore, it is generally recommended to use Romex connectors that have smooth, rounded edges or to install a separate bushing to protect the conductors. In some cases, boxes or fittings are designed to provide the same level of protection as a bushing. For example, some junction boxes have rounded edges or integral bushings that eliminate the need for a separate bushing. Similarly, some weatherproof fittings have a smooth, bell-shaped entry that protects conductors as they enter the fitting. In these cases, the NEC recognizes that a separate bushing is not required because the box or fitting provides equivalent protection. It is important to carefully examine the design and construction of boxes and fittings to determine whether they provide adequate protection for conductors. If there is any doubt, it is always best to err on the side of caution and install a bushing to ensure that the conductors are properly protected. Another important consideration is the material of the bushing. Bushings are typically made of plastic or metal. Plastic bushings are generally suitable for most applications, but metal bushings may be required in certain situations. For example, metal bushings are often used in grounding applications to provide a reliable electrical connection between the conduit and the enclosure. Metal bushings may also be required in hazardous locations where there is a risk of explosion or fire. In addition to the specific requirements for insulated bushings, the NEC also contains general requirements for workmanship and installation. Section 110.12 of the NEC requires that electrical equipment be installed in a neat and workmanlike manner. This includes ensuring that all conductors are properly supported and protected, and that all connections are made with approved methods. Improper installation can lead to damage to conductors, loose connections, and other problems that can compromise the safety and reliability of the electrical system. When installing bushings, it is important to follow the manufacturer's instructions and to use the correct tools and techniques. Bushings should be securely fastened to the enclosure or fitting to prevent them from coming loose or falling out. Conductors should be carefully pulled through the bushing to avoid damaging the insulation. If necessary, a lubricant can be used to reduce friction and make it easier to pull the conductors. It is also important to inspect bushings regularly for signs of wear or damage. Over time, bushings can become cracked, brittle, or otherwise damaged, which can reduce their effectiveness in protecting conductors. Damaged bushings should be replaced promptly to prevent potential problems. In summary, insulated bushings are an important component of electrical systems that are used to protect conductors from damage as they enter or exit enclosures and fittings. The NEC requires the use of insulated bushings for conductors of size 4 American wire gauge or larger, and also requires bushings or equivalent protection where conduits enter boxes or fittings. While insulated bushings are not specifically required for EMT fittings or Romex connectors in all cases, it is generally good practice to use bushings or fittings with rounded edges to protect all conductors, regardless of size. By following the NEC requirements and using good workmanship practices, it is possible to ensure that electrical systems are safe, reliable, and compliant with applicable code and standards. Let's consider a practical example to illustrate the application of these principles. Suppose you are installing a service panel in a residential building. The service panel will be fed by a 2-inch rigid metal conduit, RMC, containing 3 number 2 American wire gauge conductors and 1 number 6 American wire gauge grounding conductor. According to section 300.4, F of the NEC insulated bushings are required for the number 2 American wire gauge conductors because they are larger than number 4 American wire gauge. Therefore, you would need to install insulated bushings on the RNC fittings where the conductors enter the service panel. The number 6 American wire gauge grounding conductor does not require an insulated bushing because it is smaller than number 4 American wire gauge. However, it is still important to ensure that the grounding conductor is properly protected from damage. You could use a grounding bushing with a smooth, rounded edge to protect the grounding conductor as it enters the service panel. Now, let's consider another example. Suppose you are installing a lighting circuit in a commercial building. The circuit will be wired with number 12 American wire gauge conductors and electrical metallic tubing, and the EMT will be connected to junction boxes using EMT fittings. In this case, insulated bushings are not specifically required by the NEC because the conductors are smaller than number 4 American wire gauge. However, it is still important to ensure that the EMT fittings provide a smooth, rounded surface to protect the conductor's insulation. You could use EMT fittings with integral bushings or rounded edges to meet this requirement. Alternatively, you could install separate bushings on the EMT fittings to provide additional protection for the conductors. Finally, let's consider an example involving Romex cable. Suppose you are installing a branch circuit in a residential building using Romex cable. The Romex cable will be connected to a receptacle box using a Romex connector. In this case, the NEC does not specifically require the use of a bushing. However, it is still important to ensure that the Romex cable is properly protected from damage as it enters the receptacle box. You could use a Romex connector with smooth, rounded edges to protect the cable. Alternatively, you could install a separate bushing on the Romex connector to provide additional protection for the cable. In each of these examples, the key is to consider the size of the conductors, the type of raceway or cable being used, and the design of the fittings and enclosures. By following the NEC requirements and using good workmanship practices, it is possible to ensure that electrical systems are safe, reliable, and compliant with applicable codes and standards. Furthermore, the selection and installation of insulated bushings are essential components of a safe and compliant electrical system. Adhering to the NEC guidelines ensures that conductors are protected from physical damage, reducing the risk of electrical faults and enhancing the overall reliability of the electrical installation. Remember that while the NEC provides a comprehensive framework, local codes and regulations may impose additional requirements. Always consult with local authorities and qualified professionals to ensure full compliance with all applicable standards. By staying informed and proactive, you can contribute to a safer and more efficient electrical environment. The proper application of insulated bushings is not merely a matter of compliance, it is a fundamental aspect of responsible electrical work. Taking the time to understand and implement these requirements demonstrates a commitment to safety and professionalism.